Welcome back, all of you wonderful chemists. Today we are on our Day 3 notes of Unit 8. We will be predicting products of synthesis and decomposition reactions. So we've already learned how to identify synthesis and decomposition reactions, but today we're going to figure out what the products of those reactions are going to be if we are given the reactants. So the first reaction we're going to look at today is synthesis, the reaction where two pieces join together to form one. If you would like to think of this reaction as marriage to help you remember, you are more than welcome to do so. And when we have a synthesis reaction, one of the things that's going to help us identify if we have this reaction is two single elements as our reactants. So if we see two single elements as our reactants on our left side of our chemical equation, we have a good idea that this is going to be a synthesis reaction. These are going to combine to form one bigger thing. So in this example, example 1, we have sodium and chlorine by themselves. So that's telling me that I have a synthesis reaction on my hands. I also want y'all to make note of that subscript of 2 next to chlorine. So chlorine is what we call a diatomic element, di meaning 2. If you have an element by itself and it is diatomic, you need to make sure that you include this 2 subscript. If you are having trouble remembering which elements are your diatomics, you can use the phrase, I bring clay for our new home. This will help you remember that your 7 diatomic elements are iodine, bromine, chlorine, fluorine, oxygen, nitrogen, and hydrogen. If you have any of these elements by themselves, they need to have that 2 subscript. So that way they are paired up with a buddy. They do not exist alone in nature. So our example up here is hydrogen is H2. So I'm just going to label these our diatomics so we do not forget, and put an example. Hydrogen is H2. Just like chlorine and oxygen over here, these are diatomics, so we make sure we have that 2 subscript. So now that we have our reactants, our sodium and our chlorine, we need to predict the product of this synthesis reaction. In order to do that, we're going to have to consider the charges of the elements over here on our left side. If you forgot your common charges, we have this handy-dandy table up top to help us. It's the common oxidation numbers. These are going to be our common ionic charges of these elements up here. So sodium as a group 1 element is going to have that common ionic charge of +1. And chlorine is a group 17 element. It has a common ionic charge of -1. So if we think back to our naming and formula writing unit, we are going to consider our ions and make sure that they cancel out to 0, to a neutral compound. So in order for these 2 elements to form a neutral compound, I'm going to need 1 sodium and 1 chlorine. So this is sodium chloride, our salt here. That is our product. Now the last thing we need to do is make sure our equation is balanced. So I see that I have 1 sodium on both sides of my equation, but on my left side, my reactants, I have 2 chlorine, and on my right side, I have 1 chlorine. So I'm going to come over here, make sure I put a 2 in front of sodium chloride to increase my number of chlorine to 2 on both sides, but that also increases my number of sodium by 2. So I'm going to go over here and make sure I include that 2 over there. You're welcome to put a 1 here as a placeholder, but you do not need it. If there is no 1 written, we understand that it is only 1. But now I see that I have 2 sodium, 1 chlorine, and 2 sodium and, 2 chlorine, I apologize, and 2 chlorine on both sides. So that 2 subscript lets me know I have 2 chlorine. So now I'm balanced, and I'm all good. The important thing to remember is that once you have your final compound, you cannot change the subscript. Remember, these charges have to cancel. You have 1 sodium and 1 chlorine. You can change the coefficient though, this big number in the front. You can do anything you want with that basically. Make sure it's a whole number and make sure you balance both sides. So now that we've done example 1, let's go ahead and move on to example 2. We have aluminum and oxygen, again another diatomic, and we want to figure out what this is going to produce, synthesize. So I have aluminum, which has a +3 charge, if I look at my table of oxidation numbers, and oxygen, which has a -2 charge. So I'm going to use the crisscross method here to get aluminum with a 2 subscript and oxygen with a 3 subscript. And that's going to get me my compound of aluminum oxide. If you want to write out all your charges to double check, make sure that they do indeed cancel, you are more than welcome to do that. But that is our product, the synthesis of aluminum and oxygen here. Now we just need to balance. You are welcome to do the box method, do whatever you need to show your work, but since we already covered balancing, I'm going to go ahead and balance this one real quick. I put a 2 in front of aluminum oxide and a 3 in front of my oxygen over here to make sure both sides had 6 oxygen. And now finally I'm going to put a 4 in front of my aluminum since I have 4 aluminum on my right side. That is my balanced synthesis reaction. And finally, the third example we're going to do for synthesis before we move on to decomposition is this word equation here. So this one's a little bit different. We are given our elements written out. We're told that magnesium and oxygen react to form. If y'all will remember that react to form means I'm going to have to draw a yield arrow. I have magnesium and oxygen that are going to react to form. Before I come over here and figure out my product though, I'm going to take a look at both of these elements and determine whether or not I have some diatomics that I need to add subscripts to. So I see magnesium right here. It is not in my list of diatomics, but oxygen is. So I do need to make sure I add that subscript of 2 to my oxygen. And then finally, I'm going to figure out my charges on my elements. I have magnesium with a +2 charge and oxygen with a -2 charge. So I'm going to need 1 magnesium and 1 oxygen to cancel each other out. I also like to leave a little bit of space in front of my elements and my compounds when I draw my symbols, so that way I have room to balance at the end. And that's going to be important here because I do need to balance this equation. I see I have 2 oxygen over here, so I'm going to go ahead and put a coefficient of 2 over there. That increases my oxygen to 2 on my product side. Same thing with magnesium, that's going to increase my magnesium, so I'm going to need a 2 over here to make sure that is balanced. And that is my final balanced synthesis reaction. Now we are going to move on to decomposition. So decomposition, this involves one compound splitting into 2 or more pieces. If you would like to think of this as divorce, to help you remember, you can do that. Now these reactions are going to happen because we are adding some energy. We're adding either heat or electricity to break some bonds. And in doing that, we are going to split apart a compound. So to identify if we have a decomposition reaction, we're going to take a look and check if we have a compound as our reactant. If we have a word equation, we might see the words addition of energy, decomposes, or breaks down. Those are going to be our key words that let us know decomposition is happening. So for our first example, we have a formula, and I do see that it is a compound. So we have a compound as our reactant. We're going to have some decomposition happening. For decomposition, it's going to split into 2. So here we have calcium nitride. It's going to split into calcium and nitrogen. Again, I'm leaving a little bit of space in front of my elements in case I need to balance at the end. It's also important to make sure we check that we have a diatomic or not. Calcium is not one of our diatomics, but nitrogen is. So we need to make sure we add that subscript of 2 there. So these are our products, and now we need to make sure we are balanced. So I see on my right side I have 2 nitrogen. On my left side I have 2 nitrogen. On my left side I have 3 calcium, and on my right side I have 1 calcium. So I'm going to go ahead and put a coefficient of 3 in front of my calcium to make sure I'm all balanced. And that is my balanced decomposition reaction. Moving on to example 2, here we have potassium oxide. Again, we're going to have this one compound as our reactant, and it's going to split into some pieces. So right here, we're going to split into potassium and oxygen. I'm going to double check that I have a diatomic or not. Up here, I do not see potassium, but I do see oxygen. So we're going to make sure we put that subscript of 2 next to oxygen. Make sure I include my plus symbol as well, my addition symbol. And then we're just going to check that we are balanced. So right here I have 2 oxygen, and over here I only have 1. So I'm going to go ahead and increase my number of oxygen on my reactant side. That will in turn increase the number of potassium I have, so I'm going to make sure I put a 4 in front of the symbol K. So I have 4 potassium on both sides. That is my final example for my formula. Now we are going to look at a word equation. So example 3 here says that lithium sulfide decomposes to form. So there's that key word, decomposes. That lets us know decomposition is happening. And to form, again, that's going to be a yield arrow that we're going to have to draw. So right here, I'm going to write my ions for lithium and sulfur, our sulfide ion and our lithium ion. Lithium is a group 1 metal, so it's going to have that +1 common ionic charge. And sulfur is a group 16 element, so it's going to have that common ionic charge of -2. So again, I'm going to use my crisscross method. That's going to leave me with 2 lithium and 1 sulfur. Again, if you need to do that workout and see that -2 and the 2 + 1s are going to cancel to 0, that is fine. I just used the crisscross method. So we're going to draw our yield arrow and figure out our products, what we're going to decompose into. So lithium sulfide, we're going to split up the lithium and the sulfur. And we're going to make sure we have whether or not we have any diatomics, and then we're going to balance. So I'm going to come up here. I don't see lithium listed in my diatomics, and I don't see sulfur. So we don't need to add a subscript of 2 to either of those elements. We do still need to balance, though. So I'm going to go ahead and put a 2 in front of lithium. That way there are 2 on both sides. My sulfur, I already have 1 on both sides. So we are good. Thank you for watching, and if you have any questions, please come ask one of us to help you out during tutorials or next class. Thanks a lot.